Good morning. Myself Dr. K. Swathi, working as Associate Professor in Sri Padmavati Mahila Vishwavidyalayam, Department of Institute of Pharmaceutical Technology. So today's topic is gas chromatography. So this is the chapter 2 from Pharmaceutical Validation, semester 1 of Department of Analysis. Gas chromatography. Coming to contents: introduction, principle, qualification of gas chromatography, and the references. Introduction. Gas chromatography is a technique used to separate and analyze compounds that can be vaporized without decomposition. Widely used technique for separation of gases and volatile substances. So this is the picture of gas chromatography, how it is there. So syringe barrel, syringe needle, septum, top of the instrument, syringe purge, split vent, glass liner, carrier gas in injector, heater block, oven liner, capillary column, and split point. Coming to the principle. The principle of separation in gas chromatography is partition. The mixture of components to be separated is converted to vapor and mixed with gaseous mobile phase. The component which is more soluble in stationary phase travels slower and eluted later. The component which is less soluble in stationary phase travel faster and eluted out first. No two components have same partition coefficient conditions, so the components are separated according to their partition coefficient. Partition coefficient is the ratio of solubility of a substance distributed between two immiscible liquids at a constant temperature. So this gas chromatography is mainly used for the compounds readily vaporizable in a solution form. That type of compounds only selected for the gas chromatography, and they are mainly separated based on the principle of partition. Coming to qualification. Documented evidence that premises, system or equipment are able to achieve the predetermined specifications, properly installed, and are work correctly and lead to the expected results. The entire qualification consists of 4 parts: design qualification, installation qualification, operational qualification, performance qualification. So in the same way, the vendor site, owner site, and user site should be checked. In that also same again, in the vendor site, the mainly design qualification before purchase, whereas the owner site, that is installation qualification, operational qualification, performance qualification readily done. And owner site, the mainly the performance qualification, the instrument how it is working, we have to do. Designed qualification. Supplier must provide documented evidence that the product has been designed, developed and manufactured and in quality environment. Example, ISO 9001 and 2001. That means the quality and all should be ensured as per ISO requirements. The supplier must provide phone and on-site support in case of defects. Supplier must provide information through the intent on availability of new and firmware upgrades. Installation qualification. Compare a received equipment matches purchase order, software, accessories, parts, consumable. Inspect, verify documentation, completeness and equipment condition. Damage free. Install. Follow manufacturer's instructions for hardware setup. Startup, power of instruments and confirm successful self-test. Document, record any deviations for further action. Next, proceed with testing, address deviations and train personnel. Coming to operational qualification, the precision is very important, and test procedures is 5 injections of a standard calculation of relative standard deviation. Acceptance test limits is less than 1% RSD, and test frequency is yearly. Precision of peak retention time should be maintained. Test procedure, acceptance limit and test frequency. In this 5 injections of a standard calculation, relative standard deviation less than 2% RSD, and it can be checked yearly. Precision of peak areas. Test procedure is temperature and column oven is measured and compared with the set point. Acceptance limit is plus 2 or minus 1. Rest frequency yearly remarks. The temperature measurement device should be calibrated and traceable to a national standard. Next, accuracy of the temperature of the column oven. In that precision test procedure, actual temperatures measured and compared with set point at 50, 70 and 90. Acceptance limit is 2 degrees Celsius. Test frequency yearly. Remarks, the temperature measured device should be calibrated and traceable and traceable, and it should be maintained like national standards. Next, precision of heated zone temperature. Test procedure is 5 injections of a standard, calculation of relative standard deviation, acceptance test less than 2% RSD, test frequency is yearly. Precision of injection, carryover of injection. In this test procedure, blank solvent is injected after standard. Peak ratio is measured between blank and standard injection. This is less than 5% and test frequency is yearly maintained. Performance qualifications. Solution A, 10 ml methanol ethanol acetone make up to 100 ml with ethyl acetate. Solution B, prepared as per 15 ml methanol ethanol acetone make up to 100 ml with ethyl acetate. Solution C, solution D, solution E is maintained like this. The same solvent ratio should be maintained. Procedure. Blank is injected followed by detector linearity solutions and the peak response are recorded. A standard plot is drawn between the concentrations versus the response. Acceptance criteria is the plot should be linear and the regression coefficient should not be less than 0.9999. Flow rate accuracy. The digital flow meter is connected to the detector outlet port. The carrier glass flow is set and wait till it reaches the set flow. The observed flow in replicate is noted. The procedure is repeated for other carrier gases such as hydrogen and air. The flow rate of carrier glass should be plus or minus 10% of set flow. Next, system precision. 20 ml of methanol, ethanol and acetone is transferred to 100 ml volumetric flask and make up with ethyl acetate. Blank is injected followed by standard preparation in 6 replicates. The percentage RSD of retention should not be more than 1.0%, the peak not more than 5.0%. Detector noise and drift test. After GC is ready, the system is run up to 15 minutes through the single run. When the run is completed, noise and drift is calculated through software. The acceptance values are noise not more than 100 microgram, drift not more than 250 microgram. So they are the references.